Today I'm going to demonstrate an attack that I've called fake sudo. This fake sudo attack is a social engineering attack in which this USB will communicate with a server and install several executables that fake a sudo. Normally when running sudo, it gives the users elevated permissions to run applications with root. However, this will install another sudo that acts like sudo, but instead will obtain the user's password using social engineering and pass that on to gain root to run other executables, to then install additional malicious software or just wreak havoc on the computer. Upon plugging this in, this will open up a terminal, connect to a server, pull down some files, install those files, and set some aliases so that when the user types sudo, instead of running the normal sudo, it will run my custom sudo and communicate with a payload that will wreak havoc upon obtaining root access. I will be using my PC today to demonstrate this attack. Upon plugging in this USB into my computer, we will switch over to a better screen recruiting view of the action, in which I will explain further what is going on.
So the first thing it does is it opens up the terminal and it begins creating an SSH private key file. As you can see, it's injecting a private key into a thing called a TAC key. This will be used to download files from the server later on. So right now, it's grabbing down a script, and the script then downloads further 2 more executables. It clears the history and then exits. Part of the attack script will go into further, but the attack script gets rid of the SSH key as well as leaves no trace that it was ran. So that is a plus. At this point in time, the attacked PC is now compromised. Any normal use of sudo, rather than running the real sudo, will run the fake sudo that I have programmed. We will now demonstrate this. So, typing sudo, it looks normal, but that's just some additional features that I programmed to have it act normal, just like a normal sudo. But the real attack happens when we do sudo apt or sudo any command that we would normally run to get root privileges. But just to show some more features that I programmed, like help, it also shows what you'd expect, or sudo-v also shows the version, but this is all just fake in order to better social engineer the attacked user. But if we actually run, let's just say sudo apt update, it'll prompt us for the password, and if I enter the password, rather than updating the computer, it's going to launch the compromised payload. And this payload is a malicious software, but it's going to retrieve the password from this fake sudo, and then it's going to be able to pass the password to the real sudo, gain root privileges, and then run the payload with root. And as you can imagine, this can do basically anything. This is a big problem. In this case, for demonstrations, I have it wipe the computer by removing root. I give it 60 seconds because this is my PC and I don't want to actually wipe it. But I will show that it actually does wipe the PC in a VM. But let's just hit enter and see what happens. So, right here, instead of updating it, it says, you are root. This PC will be wiped in 60 seconds. This is all in the payload. We're obviously going to kill this. We don't want my PC to be wiped. But that is just a demonstration of this attack. In a real world case scenario, we wouldn't tell the user. In fact, maybe we would flash some more fake messages to give them a false sense of security. And maybe we install a backdoor, or we encrypt their files, or we just wipe the computer and they can't do anything about it. But that is the basis of the attack, and I will go into a little bit of each part, how each part works now. But that is the attack in action. So, on an actual VM, I'll run the fake sudo to completion, where we'll actually wipe the computer because it's a VM and I don't care. So on this PC, the exploit's already installed with the USB, and so we type sudo, it looks normal, but if we do sudo apt, again, it looks real. We'll type in the password, and URL root, and it will wipe the computer in 60 seconds. And I will now skip ahead and show you how it works. So it's about to wipe the computer. And if you ever have done this before, you'll recognize these messages. Right now, it's really destroying the computer. And soon, the computer will, the VM will crash and will need to be reinstalled. So not a nice thing to do to somebody. Definitely malicious. If we look around, see LS is missing. Things are... that still works. Things are slowly going to break here. It should crash here soon, and we'd have to wipe it. So let's just see. Normally doesn't take too long. Let's see. And there we go. It crashed. So there you go. That is an example of how plugging in USB, less than 20 seconds, users none the wiser, they wipe their PC. Definitely not a fun thing to happen to you. So now we'll go into more detail on how it actually works. So what we see here is we see the script that's ran on the USB. So delay, GUI means the Windows key, and then string means, you're typing on the keyboard and then enter is enter. So we open up a terminal here, enter it, and then we start building the private key, and you would put your own private key here, and we're putting it into the file called attack key, appending it to attack key. So this is the end of the key. We clear the screen, and we get rid of the history because we don't want the person who was attacked to know that we were here, so we clear it. And then using the attack key, we pull down a attack script, and we'll go into what the attack script does later. We then wait a second for it to download, and then we set the permissions to allow us to run this script. Again, we don't need sudo to do this at this point. We then run the attack script, and this will we'll go into what the attack script does soon, but that does some things we'll go into. We clear the history again. We get rid of the bash history because that's another way that they could see that we were here. And then we exit the terminal, and all this takes less than 20 seconds. Here is the attack script. So what this does is that it first makes a folder that will be used to hide the malware, and then uses the attack key that we generated to grab the malware. We have the payload, which will be the executable that gains root, and then we have the fake sudo, which is used to trick the user into giving us their password right here. It hides these payloads into this folder, and then right here it adds these things to the bash RC, which is started upon making a new terminal. It sets an environment variable to payload, and it sets it to the path here, and then sets an alias for sudo. So instead of running the normal sudo, it'll run our fake sudo. And again, that's in the bash RC. It then removes the key, and then it removes itself. So this is the code for the fake sudo binary that I made. So let's go down to main, and we can see that we have some code that if there's nothing passed, it displays the generic sudo message. If it just has the H, it shows the help menu. If it's just a V, it gives the version, and all that's in the functions up above we'll go into. But let's go to the main core of it. If it actually does sudo apt or sudo something that would prompt a user for a password, we first get the username of the person who ran it, so that we can say, password for, in this case, Blake, me. Or if it was attacking someone else, it would get their username so it looks real. So we get the username, and then we get the path to the payload, and we set that in the attack script. So right here we're building the password prompt, and that'll be all done from up here. This right here hides the terminal input, so that normally when you type the password for sudo, it doesn't show the password. We just want to make it look as real as possible. So we take in the password, and then we turn the terminal back on so that it behaves normally. And now we have the password, and we have the path to the payload. And we go up here, and we build the command. So here's some default behavior. If nothing's passed, it'll just run apt update. But we passed the payload, so it's going to run with the real sudo. It's going to get passed in the password. It's going to build the command. The command is echo the password. We then pipe it in to the real sudo, and then we run the payload. In this case, the payload was the environment variable that we set in the attack script. And then it runs that command with a system call, and now we have running our payload with root privileges through using the real sudo. And we have the password obtained from this fake sudo. Here's some of the fake messages that I made to just make it look more real. Yeah, and now we'll go on to the payload. So here we have the code for the payload, the real code that's going to attack the PC. The rest of the code was just to gain root access. So this builds the binary, and we can see right here we get UID. So if we actually are root, the ID will be 0, and it'll print you are root. So earlier when it says you are root, that's because we check the ID. And then we'll be wiping 60 seconds. We have counter. Counter just goes through 60 loops and then sleeps for 1 second. And then if you actually let it get all the way down, it does RM, RF, and gets rid of root. If we're not root, it will say you're not root. So this payload is a malicious payload. It just causes havoc, wipes the PC. But there's plenty of other use cases when you have root. I mean, when you have root, you can do whatever you want. We could install software in the background. We could send the obtained password to a server. We could a more as overt, not as obvious attack would maybe we send the password to a server and then use root to install some software to gain access to the computer later, and we use the root access to better hide ourselves, better ingrain ourselves into the computer. We now have the user's password, and now we basically have full control over this computer. If we use additional software, root the additional software, because we have root access, so we can deeply ingrain ourselves into the PC. Like I said, in this case, we just destroy the computer, but what I'm trying to say is we can do whatever we want. We're root. So we're destroying the computer here, but there's plenty of other applications we can do with this fake sudo. So thank you for watching this video. I think it was a cool example of social engineering and a good demonstration of why you should not leave your computer unattended and unlocked for any period of time. I think the total time for the bad USB to install itself was a little under 20 seconds, and I mean, how many of us have left our computer for more than 20 seconds? I mean, 20 seconds isn't that long, but that's plenty of time. So thank you for watching. I'll have some links in the description for the code, as well as a few other things, some credits for some of the things that I use, such as the USB. Thank you for watching.